Happy Friday, guys. Welcome back to a feverishly busy PC1. I'll just take a few moments to give you a quick update from the week on what we've been up to building GT50 and HX50. Let's start down in the casting shop and I'll show you the range of components that we've now completed casting ready for the prototype engine. We'll take a walk through the machine shop and I'll show you all of the prototype components going into the very first GT50 gas generator and later the power turbine, and then we'll have a look at our blade 4 and 5 from the composite main rotor blade shop, and we'll talk about the Crashworthy seat before I give you a broader update on the Digi-cockpit and all the other things that are going on the Gen 2 airframe. So Mark and Adam and the broader casting team have really got to grips with the turbine blade casting process now, both for the LP turbine blades and the HP turbine blades. We've now cast well over 180 blades that are all of a usable quality for the engine. We've done the heat treatment on these blades. We've got the mechanical test data back on these that show that the grain structure's right, that the mechanical properties are right, and that they've gone through sufficient NDT testing to know that they're poor and defect free. So it's full steam ahead now with preparing these blades for the engines, doing the final machining on the fir trees and then EDMing the details in the bottom. We'll go into the machine shop in a second and I'll show you how we're doing that. So with the casting shop now casting turbine blades like they're shelling peas, we're now running through all of the different stages of completing the manufacturing these stage by stage. So this morning we dispatched the first batch of turbine blades for the first prototype engine out to heat treatment, and then we're sending this second batch out at a later date so that we can get the feedback from the heat treatment to make sure if it's not right they don't scrap all of our blades in one go. So those are out of heat treatment at the moment. These will be following them out shortly, and once they come back they then go over to root grinding and EDM to get the remaining details to convert this raw cast blade into a finished turbine blade for the engine. Let's go and have a look over here. So once we've got the raw casting, the next thing that we do, as you've seen previously, is we have to grind in the fir tree roots at the bottom of the blade so that we can connect these blades to the turbine disc. And then the platforms that hold the spacing in between each of the blades also have to be ground to very, very tight tolerances so that they fit just right and manage the gaps really carefully. And then the final stage in the manufacturing process, pending the final quality controls, is to electrically discharge machine the slots in the bottom of the fir tree that allow us to spring lock these parts into the turbine disc. And that's what you can see happening here on this batch of blades, where we drop an electrode into the bottom of the blade. The blade's mounted in a fixture upside down there, and then we EDM out the pockets that allow us to fit the spring retaining clips that hold these in the disc when the engine's not rotating. Okay, so those are underway at the moment. That's the final stage of manufacturing for a full batch of prototype GT50 gas generator turbine blades. The turbine blades fit in the turbine discs, and here is the first 4 gas generator turbine discs for GT50. So these have had all of the manufacturing and inspection operations they require, and they're just pending having the fir tree roots cut into them to receive the turbine blades. So the fir tree roots are these features over here, and this is the test piece where they've been setting up the pitch in between the roots and getting the process clocked in perfectly, working very closely with Ollie and the rest of the metrology team. And what you can see right there is one of our finished HP turbine blades sat in the female groove in the fir tree, and that just slides in and out really easily and is spring locked into really tight tolerances so that it holds on just right. Welcome to the production control office. What we've got here is the war room, if you like. It's where we manage all of the components that are going through the shop at the moment. So what you can see here is a lot of the gas generator rotor components for GT50. You've got the rear stub shaft, the impeller, the intermediate stub shaft, forward stub shaft, the HP disc that we just showed you, and then the full rotor assembly that's being put together to go off and be balanced so that it runs smoothly up at 50,000 RPM. And then of course we've got the balance disc there. We have the disc assembly there for the high pressure turbine, the gas generator turbine. And we have to be very careful about where we put each of the blades so that we balance the weight as optimally as possible around the disc circumference. Down here you can see some of the tree arrangements for the blade castings that we're producing. Those are going through like shelling peas in the foundry at the moment. The guys are doing an amazing job with that. On the other end of the board down here, you can see the first batch of wheeled HX50 undercarriage components that are starting to trickle through. These are very much behind the engine components in the queue. This is a lower priority, but all of these components have been released. They're all working their way through the machine shop. I think we've got some brake calipers and so on that we can show you in the metrology lab at the moment. We'll come to that shortly. Down here we've got the remaining components for the gas generator, so the real heart of GT50. All of these components are either in work, completed, or very close to completion now. Intermediate casings, shrouds, bearing housings, seals, bearings themselves, and everything that goes into that first half of GT50 on the board, working its way through the shop. Let's go and have a look at some of the hardware out there. So we've shown you these components before. This is the impeller shroud. We've got the abradable coating that sits on there to prevent titanium fires through rubs. The next component in the sequence that's just been finished is what we call the intermediate casing. And this essentially sits around the compressor shroud and forms the forward part of the front of the engine. And then as the discharge from the compressor comes out, it's the intermediate casing and the combustor casing that trap the diffuser that feeds that compressed air in a uniform and controlled manner into the combustion system. That intermediate casing butts up against the combustion casing, trapping the diffuser, and delivers high pressure air to the combustion liner itself. Now, you've seen us make all of the rings for the inner side, and then the larger rings that you can see over there that form the outer side of the combustor. But actually the bits that are most difficult to make in this thing aren't the rolled rings that you've seen us do multiple times, but it's these very tight, long, deep drawn components on the inside of the gooseneck, on the outside of the gooseneck, and even more so, these really tight curves on the inside of the gooseneck. And that's what the guys have been focusing on over the last few weeks. We've been using a lot of simulation methods to be able to develop the correct way of designing the press tools and holding the metal in the press before you apply the pressure to make the components. And because of all that work, jumping backwards and forwards between the analysis world and real world on the shop floor, we've now got to the point where we're able to produce these complex deep drawn forms in super alloys that are required to make those final few parts of the combustion liner itself. So super pleased with the progress on this. The guys both in the design and analysis office and on the shop floor have done an incredible job of making, although it looks really simple, it's actually a very difficult thing to do well. Last few bits now to get the liner finished, and then we'll be in a position to start a fire. What we've got here is the latest of the intermediate stub shafts just having its final operations to produce all of the curvic details and the intricate passages for the secondary air system. One of the final parts to manufacture for the first gas generator rotor is the rear stub shaft. And when you look at this and the level of detail that goes into these components, you've got sophisticated curvic couplings that the shaft relies upon to maintain its concentricity and alignment, and also to transmit the torque between component to component. You've got the intricate holes here that feed the secondary air system and pump cooling air around the engine, and then you've got these different arrays of precision labyrinth seals that keep all of the air and all of the oil where it should be in and around the shaft. So just before Christmas, we showed you the very first titanium GT50 compressor wheel. We used that to develop out the machining processes to get the surface finish and the accuracy that we needed. We've now produced impeller number 2, and this one has been subjected to the full inspection regime that we need to make a compressor that's fit for the engine. Each one of these blades has been subjected to a coordinate inspection at 200 individual points. And on this particular one, 98.2% of those points all fall squarely in the tolerance band. So we've got a few small outer tolerance points, and they are purely down to the fact that we had some tool wear while we were machining the profile. So on the third and hopefully final prototype compressor, we'll just be changing the tool a little bit more frequently, and then that's it. That's the one that will run in the prototype GT50 engine. And to put this in perspective, we're now making this to in places to single figure micron tolerances, and this whole thing started life as a huge billet of heat treated titanium, just like that. So that's the before and that's the after. And that's what vertical integration really looks like. And then here on the CMM, we've got a final inspection going on the front stub shaft for the first GT50 gas generator rotor. And then over there waiting for inspection, we've got the first rear stub shaft in the series that's going through final inspection right now. In the last couple of AMAs, we've given you some quite extensive feedback about the work that we've been doing on the overall crash safety and cabin safety associated with the Gen 2 fuselage. So looking at how the seat systems protect the occupants during any kind of crash conditions. All of that work's matured nicely. We've now got 10 prototype crash-worthy seats going through the factory at the moment. That includes all of the mechanical components, the legs, the sliders, the adjustment mechanisms, the seat belts, everything that goes into that seat that we'll do the static tests on here. So those are all the flight inertias and the crash cases we have to live with out of the CS27 code. And then once we've passed all of those, we'll be sending a group of those seats off to the crash test laboratory, putting automotive crash test dummies in them, and then slamming those into the wall with a sled to prove that every element of the energy absorbers works properly, and all of the structural elements work exactly as the simulations have predicted. So really pleased to have finally brought that to a close, but it doesn't stop there. In addition to the composite side of the engineering, in addition to all of the mechanical components, in addition to all the metallic structural components, the attachment for the forward seats to the floor on the sliding seat rails, and the attachment of the rear seats to the bulkhead, in addition to all of that, we've also got to get the production seat covers ready. So what we've got here, this is, if you come around and have a look at the back, this is actually just a solid model board replica of what the finished carbon fibre shape will be, plus the seat rails that go up the back. And this allows you to see how we fit the production seat covers to the seat. So the whole seat tray and seat back is made as a single seat cover. It goes over the seat, and then we can simply fold the seat covers round and attach them into the recess behind the seat and underneath the seat, so that it makes it really easy to swap the foams and to swap the seat covers when it comes time for overhaul or interior upgrades. So this is the latest comfort surface. We've still got a little bit of work to do on the stitch lines. Because this is a solid back, you don't get any of the bum crease features that you can see down here, where it tucks in and gives the shape some form and anatomy. We've got a little bit more work to do in that centre section there. You've got options for a 3-point or a 4-point harness being attached here. The headrest that you're all used to, headsets go over the top, and then on the rear, we've updated the rear of the seat. So the seat rails, your seat belts mount up the top here, and all of that gets covered with a removable seat panel that goes on the back like so, and then you've got a nice flexible pocket here, which is where you can put your water bottles or anything else, and that kind of completes the sort of flowing anatomical look of the seat. And then we've just got to add your contrast stitching, your different materials, and then we're away and ready for testing. So we've got very large quantities of high-grade aerospace material arriving at PC1 now most days as we push more and more of these components through production. So over here we've got small billets that will form some of the metallic inserts that go inside the carbon fibre bucket to attach all of the mechanical fasteners to. We've got some stainless steel material here that's being used for making the diffusers, which is the next component up on the engine after the compressor. We've got some higher grade alloys here for casting more turbine blades, and then these big chunks of material over here, these are waiting to become 10 sets of Crashworthy aerospace grade seat legs for our Crashworthy seats. Let's go and have a look at some of the components on the 5-axis. So for the prototype seats, we're relying quite heavily on 5-axis CNC machined components, purely for speed of execution to prove that everything does what we want it to do. So we take a lump of material like that and then essentially turn it into a tiny component like that. So you can see that between those two, the fly to buy ratio is pretty awful for these materials. Now in practice, we've actually identified some advanced grades of new aluminium alloys that can achieve very, very similar properties to high-spec 7075 aerospace grade aluminium, but directly from an investment casting process. So in production, rather than wasting all of that machine and turning it into swarf on a 5-axis, we'll simply cast these on trees of 20, 30, 40 parts at a time, making the process much more efficient, much more sustainable, and much more cost effective. In order to make 10 Crashworthy seats, you need 10 lots of seat foam. Now in production, we'll be molding these directly into tools that we've made to avoid wastage and to avoid tying up the gantry mill, machining away big lots, large amounts of foam like this. But for prototype purposes, it's far more effective and flexible to machine these. So we've taken delivery of the comfort foam, the carbon loaded flame retardant comfort foam we use in the seats. And then Paul and the team are busy machining these components here into the seat backs that fit neatly into the carbon structure that we've just shown you. And then the seat trays, that's the bottom surface, and there's a finished one with the upper surface. And what you can see here is we actually have to machine in what we call salvage grooves. And these are the grooves where when you create a bum crease between two bits of leather, there's somewhere for that extra material to go in and to be pulled into, so the leather follows the contours of the seat without giving you a hard edge and making you uncomfortable. So we've got that in the seat base. We're going to just work that into the seat back a little bit more to plump that seat back up. But these two all going through manufacturing right now, ready for the testing. With the mechanical components going through the machine shop for both the inserts, the legs, and all of the apparatus that the seat sits on, and then the comfort foams going through the gantry mill, the leather trim going through the trim shop to make the seat look right, the only thing that's left is the carbon shell itself, the bucket of the seat. So what you can see here underneath is we've got a model board tool, and then we've got a carbon mold being formed, and then we'll actually make the parts into a two-sided carbon mold. So we've got a double A surface on both sides. So this is the rear side of the seat. You can see the structural beams that make up the body of the strength of the component. You can see the little stub up here for the headrest and all of its attachment, and then the various fasteners we use to clamp that tool together when we're molding the parts. So the guys will be finishing off the molds over the next few days, and then we can start laminating the first 10 prototype seats and get those through testing. HX50 rotor blade number 5 came out of the mold a few days ago, and the guys have now got all of the elements of this manufacturing process down to a pretty fine art. The upper and lower skins are going into the tool really neatly and really accurately. We're getting the mandrel wrapping done very well. The foam cores are going in and holding position. We've still got a few tweaks to make in the carbon kitting to make sure we fully fill some of the awkward areas, like the step down where the erosion shield fits, and a couple of other nuanced details around the root end. But all in all, this is coming together really well, and the time it takes us to make the blades is dropping rapidly every time we make another one. Let's go and have a look at blade 4 and 5. So this is HX50 blade 4 and blade 5, both of which have come out really, really nicely. So what you can see is we've molded them with the integral primer film. That allows us to reduce the amount of paint finishing we need to be able to get an acceptable paint and environmental protection for the blades straight out of the mold. We've got the integrated recess for the erosion shields. We've now made the first prototype erosion shields for the full length of the blade, with the exception of the tip section down here. On top of that, we've now completed the detailed work on the design of the installation of the root end bushings that allow us to connect the rotor blade back to the airframe. So from this state, we would have to drill out 2 holes for the bushings, and then bond in some high-grade stainless steel bushings to receive the blade attachment pins. And the whole process and stress analysis and all the optimization for that has now been done. And so very shortly, we'll be making a shorter subsection of these blades with root ends at both ends of a dumbbell root section, so that we can put those on a tensile test machine and start validating the strength of the root end connection, the quality of the composite, and a range of other parameters. Now, we've halted blade production for the time being because the very next step is that both blade 4 and blade 5 are going to be subjected to a wide range of mechanical tests. Over the course of the last week or so, Stuart and Adam and the team have been building all of the test equipment that we need to do a variety of tensile, shear, torsion, natural frequency, mass and CG, and impact testing on both of these blades. Once that testing is complete, we'll be cutting the blades up again to complete some further NDT and some further inspection of how well we've got the carbon exactly where we need it. But the blade production process is now maturing very nicely, and we're racing very quickly towards the point where we can make consistent, reliable blades to the target geometry, weight, and we're not far off our target price point either. While the composite team have been focused on getting all of that complex composite manufacturing down to a fine art, here in the machine shop, they've been doing something equally difficult of producing highly precise, thin-walled stainless steel erosion shields for the blade. So these are the various sections that go up the straight section of the blade that provide protection to the composite from erosion from water, rain, and debris that's floating around in the air. So these 4 or 5 sections are now ready to be fettled and fitted to the blade, and then that just leaves us the curved tip section and the machined end caps in the blade that receive the weight pots to be added to have the full range of manufacturing processes demonstrated for our very own low-cost composite main rotor blades. As you would expect, a lot of the stuff that we've shown you has been engine. A lot of the components that are going through the machine shop to get us ready to build and test the final parts of the very first GT50. Over the coming couple of months, you'll start to see our attention slowly pivot back towards the helicopter as the engine manufacturing process comes to a close and we get ready to test. We'll be reporting lots more of the stuff that we've been doing on the airframe, on the Crashworthy seat, on the digi-cockpit, on the rotor systems, and a bunch of other stuff that we've been leaving alone while we've been keeping you really up to the minute with the engine. Expect that in the next coming weeks. We've got lots of great stuff to tell you about. Speak to you soon.